Hello guys, welcome to the channel of TCP/IP. Now, today we are going to discuss about the IP address. We know that every computer in the world will get the IP address by the ISP. So how that is going to be get and what are the what the purpose of the IP address? What is IP address? The IP address space, what the size of IP address, and the different types of the IP address, and the different notations they have. So let's begin with the these such types so that we can get the idea about the IP address. Now, if we go with the first, why there is IP address required? So there are plenty of reasons to have IP address on the computer. To identify the device uniquely on the internet, if any device is connected to the internet, that time the device is supposed to be identified uniquely. Then second purpose will be to use the services from the service provider, like web services, email services, Skype services, and so on. So if any users want to take the services from the service provider, that time IP address is required. And at the network layer, we need a unique identification of each devices on the internet to allow the global communication between all the devices. If I want to communicate with my friend, which is seated or somewhere else, that time again we require an IP addresses. For that, the global communication can be happened. To get internet access, we require destination, and that can be identified by the IP address only. So this is also a purpose. And to allow computers to send and receive information or let's say data to and from the specific computer in the given network. For that purpose also the IP address is required. So these are the purposes of the IP address. Now, if you go with the what is IP address? So IP address is let me start the annotations. IP address is a numerical representation that uniquely identifies a specific interface on the network. So if you go with the diagram, so here we can see there is an interface of the router WAN port, and here in upper lower side it is the LAN port. So on the every interface, the IP address is going to be set. Plus on this computer also, there going to be a IP address going to be set. So here 1.2 has set. Here we can say 1.1 has set, and here 10.2 has set. So on this interface, the IP address can be set. There are commands also there, no issue. Then IP addressing are unique. IP addresses are unique. They are unique in the sense that each address is defined one and only one connection to the internet. Two devices on the internet can never have the same address at the same time. This is what the constant. The IP address space is managed globally by the Internet Assigned Number, that is IANA authority, and by the 5 regional internet registry, that is RIR, responsible in their designated territories for the assignment to local internet registries such as the internet service provider and the others. So if you go with the IP address key notations, I can say this is what there is no computer in the world capable of communicating with another without an IP address. So an IP address are the numerical names assigned to the device as a license plate, so other devices can label it easily, so that the device can label it easily. If you go with the online and can see the command will be, let's say, check my IP address. So it will give us the IP address like a 201, etc., etc. So this is what the IP version 6 available over. And if you go with our computer, and can type just, let's say, cmd and run ifconfig. This is what the ifconfig. So we get the IP address of our system. So here we need to type what ipconfig. And ipconfig is what for the Windows, and ifconfig is for what the Linux environment. So another term we can say, so this is all about the IP address. Let me clear the drawing and go to the next slide. So then we'll discuss the second topic, and there is a IP address space. So if you talked about the IP address space or any address space, so it means what? It is going to be a kind of lower limit and upper limit. So what is the size of that IP address? Then specifically here we are discussing about the IP version 4. So let's start with the address space. So in computing, the address space defined a series of discrete addresses, each of which may corresponding to the network host. So this is what the definition. And address space is the total number of addresses used by the protocol. This is what they use by the protocol. Let's say if the protocol uses the B bit is to define the address space will be 2 to the power B. So B value is about the size and which is of 2 to the power. So we take example IP version 4, which is of 32-bit size. So here space will be 2 to the power 32, which is more than 4 billion value, which is more than 4 billion value. This is what the address space. These many number of addresses can be given to the computers except that special addresses. And theoretically, if there were no restrictions, more than 4 billion devices could connect to the internet. Okay, and there are two versions. There are two versions of the IP address: IP version 4 and IP version 6. If you talked about the IP version 4 and IP version 6, so in this chapter we are going to discuss about the IP version 4 only. IP version 6 we'll talk later on. So the size of the IP version 4 is what 32 bits, whereas the size of the IP version 6 is what 128 bit. This is what very huge number. Okay, so nowadays IP version 4 addresses are exhausted. We can say this is already gone. Although there are some concept of subnetting, supernetting, VLSM, etc., etc. But IP version 4 has now exhausted. Now IP version 6 is going to be used anywhere. As I shown you in demonstration part that check my IP and the IP config. So there are IP version 6 has assigned by the ISP to any computers. So this is what the address space. Now, if you go with the another slide, and there are types of IP addresses. Generally, there are IP version 4 and IP version 6 have the following type. The very first is the private IP address, and second will be the public IP address. In a private IP address, what we can say, these are used inside the networks. So one particular organization owner can use the IP addresses to their networks and to their computers. Okay, and the range is going to be used. For the example, home network is used by the personal device like the tablets, the Wi-Fi, the wireless printers, and the desktop PCs. This type of IP address is provide a way for device to communicate with the routers and the other devices on the private home network. This is what the concept. The private, whatever the address is assigned in between that self network is going to be a private address. The private address can be set manually or assigned by automatically by the DHCP. So DHCP is what a dynamic host configuration protocol where we need to configure the DHCP server. That DHCP server having the pool of IP addresses randomly or sequentially one of the IP addresses get by that particular client. The second category is what the public IP address. In this, these are used outside the network and are assigned by the ISP, Internet Service Provider. Okay, it's a main address that a home or a business network used to communicate with the rest of the network device around the world. For example, the internet. This is what the public IP address. It provides the way for the device in a home, for example, to reach an ISP, and therefore the outside world, allowing the devices to access websites and communicate directly with their computers and the server around that the world. So these are the public IP addresses. Now, this public IP addresses and private IP addresses, more about the public IP addresses, we can say the public IP addresses again divided into two subcategories, and that two subcategories are what dynamic IP addresses and the static IP addresses. Now, if you go with the dynamic IP addresses, the dynamic addresses are automatically changes frequently for the security reason. Because if we give an IP address to the computer, being ISP, if I give the IP address to the computer and it is going to be for a year and year, it is going to be same. So that is going to be analyzed by the everyone. So it is going to be better to have frequent changes of the IP address and automatically change the IP address, and that is called as what the dynamic address. Most internet user will provide with the dynamic IP addresses from their ISPs. ISP buy a big block of IP addresses and automatically assign one of each to the customers. So, and then they will periodically assign them a new one and put the older one back in the pool to the recycled for the another customer. So whatever the IP address assigned to the one customer is going to be again changed after some time, and it is going to be kept over in the pool so that that can be assigned to the another customer. So this is what the beauty of dynamic IP address. They are actually borrowed from the pool of IP addresses shared over the various computers. Since limited number of static IP addresses are available, ISP usually reserve the portion of these assigned addresses to share among their subscriber in this way. Okay, so this is what the dynamic address is. For the security reason, they have automatically changes frequently. Second category is about the static IP addresses. Static IP addresses are consistent or constant. Okay, once the network assigns such addresses, it will stay over a month and a year. It is going to be constant month and a year. Not many people or businesses need static IP addresses, but there are some rare use cases where going with the static IP addresses is important. The main use of for any business that plan to host their own servers. From the static IP addresses of the system, we can get many details such as continent, country, region, the city in which the computer is located. So this is what the clue can get by the static IP addresses. The ISP that serve that particular computer are non-technical information such as precise latitude, longitude of the country. Are there many? There are many websites providing IP addresses lookups. So these are the information can be easily got from the static IP addresses. So static IP address, we can say it is going to be very harmful rather than the dynamic IP addresses. Okay, because it is going to be consistent among many of times in the month and year of times. Now let's start with the notation. If you talked about the IP addresses, so we need to have a notation. What is the representation of the IP address? So this is going to be very important part, guys. Okay, so let's take the notification. Actually, there are three notification. Uh, IP address can be represented via binary notation. It can be represented via decimal, dotted decimal. It can be also represented by hexadecimal. So binary notation, which will be the base of 2, dotted decimal, which will be the base of 256, and the hexadecimal will be base of 60. Okay, so if you go with the IP address, an IP address, let's say if IP address comprised of 4 octet. So let's say this is what the 1 octet, this will be a second, this will be a third, and this will be fourth. Every octet is of what 8 bit in size. So that octet is called as what 1 byte. So if you get, there will be a 4 octet or 4 byte. So this is what the beauty. And the main points related with the IP address, the 4 different numbers separated by periods or dots. So this is what the dot separated everywhere, each with 1 to 3 digits. So this can never be greater than 3. This never can be greater than 3. Only up to 3 value. Let's say these are the 3 values available. All of them falling between 2 to 255. So this is what the constant. This is what the constant. No one can have a more than value this and below than value this. Okay, so this is what the main points related with that. What we have, the different numbers separated by the dots, each with 1 or 3 digits on 1 octet, and in the range of the that one particular 1 octet is what will be 0 to 255. Then let's take an example. Find an error, if any, in the following IP address. So here there is an IP address given, and this IP address was 111.56.045.78. So here there is an error. What is the error? There should be no leading zero. There should be no leading zero in dotted decimal portion. So this is what the wrong IP address. So we cannot assign any leading zero in any octet. Let's take the second one, 221.334.7.8.20. So here, as I told you that IP version 4, have only 4 octets. So here there are 5 octets. So if you go with this IP address, there are more than 4 bytes in the IP address. It is not going to be allowed. Only 4 octets are going to be allowed. If you go with the third IP address, which is 75.45.301.14. As I told you, that value supposed to be lies in between the 0 and 255. So here there is a 301. So 301 is what the outside the range is going to be again a wrong address. Then fourth address is, let's say, 111.000.10.23.14.67. This is going to be again a wrong address because we cannot assign the mixture binary notation. The mixture binary notation on these IP addresses. So this IP address is also wrong. Okay, so we need to follow all the concept of the IP address. Now let's take one by one. There is the first is a binary notation. If you talked about the binary notation, and binary notation is going to be very useful in this particular IP addresses. In binary notation, IP version 4 is displayed as 32 bits. So whatever the 4 octet we have, each of which 8 bit, so that will be of 32 bits. To make the address more readable, one or more spaces is usually inserted between each octet, 8 bits. Each octet is often referred to as a byte, okay, as we already discussed. So it is common to hear IP version 4 address referred to as a 32 bit, that is 4 octet and 4, or it is 4 byte. So let's take this example, how it is going to be assigned. So converting decimal to binary, if you take the example 192.168.10.1, this is what the decimal, and what we are positioning this particular decimal number into the binary number. So let's say this is what the 1 weightage, this is what the 2, this is what the 4, then 8, 16, 32, and 128. Whatever the bit is on in this particular weightage position, that will be treated as the on, and it will the value. Okay, so let's check. If I want to represent this 168 in the binary position, so in order to represent this decimal 168, we have 8 over here, 1, that is flag is on, 32 is on, and 128 is on. If I add this 128 plus 32 plus 8, which will become the 168. This is what the weightage of that particular decimal number in the binary. If you go with the second example, if we have any decimal number, and decimal number can be converted into the binary on the basis of same idea, where whatever the weightage of that number is there in the binary bit position, that will be assigned. Okay, so this is what 190.160.0.1, this will be the example. So I hope that this binary notation is okay with you, where only we need to keep that on bit and off bit, and here we can represent this binary with the 8 bit in size weightage. So that, and that weightage from the 1, 2, 4, 8, 16, 32, 64, and 28. This is what the first notation. Let's take with the second notation. The second notation is called as the dotted decimal notation. To make the IP address more compact and easier to read, the IP version 4 address is usually written in the decimal form with the decimal point dot separating the bytes. Let's take how it is going to happen. The format is referred to as the dotted decimal notation. With figure shows how it is going to work. So let's take. Note that because each byte octet is of 8 bits, each number is in the dotted decimal notation between 0 and 255. So if you take any binary value, that is, let's take any binary value, that is 11, let's say this one. So 00001011. If you take the decimal of this one, it will be 11. How it is going to be this? So this is going to be 1. This is going to be 2 weightage. So 1 plus 2 plus 4, and this is 8. So by adding this 8 plus 2 plus 1, which is going to be 11. Same concept will apply over here, and over here. Okay, so there is example, simple example. If you take any thing from this, let's say this is what the first example, second, third, and fourth. Take this value only, so that we can understand the portion easily. So this is going to be a guys 239. Why it is 39? Because the only portion is off is what? 1, 2, 4, 8, 16. So 16 portion is off. So if you minus this 16 from the 255, we'll get the 239 values. So if you go with any smaller value, we can say, let's say 11 again. So here, let's say this 11 over here. So we have tried this 11 earlier, so we can get this idea. So this is what the dotted decimal point notation of the IP address, which is very important to represent to the IP addresses. Let's start with the third and last notation, and that notation is called as what? The hexadecimal notation. Hexadecimal notation is also one of the notation of the IP version 4. Sometimes IP version 4 is in a hexadecimal notation, as we have seen in the IP version 6 nowadays. It is going to be shown in hexadecimal notation. So each hexadecimal DC is equivalent to the 4 bits. This means that 32-bit address space has 8 hexadecimal digits. The notation is often used in network programming. This is what very useful in the network programming, right? So in order to represent the hexadecimal notation of the IP address, we need to consider this table effectively, where decimal, hexadecimal, and binary position are given. Let's try one. So let's take one value of the binary. This is what the binary bit position. Let's take the from this 11111 011 1011 0010. Now, in order to convert this into the hexadecimal value, what the procedure is going to be followed? Each value is going to be separated in a 4 bits. So we have taken this 4 bit over here. Second 4 bit up to this. So we have taken this 4 bit over here. Okay, as like we have taken the R4 bit. So third 4, fourth one, and the last is only one remaining is what we have kept in the separate. So now represent this into the hexadecimal weightage. So this 1 will be 1 as it is, because if you go with the 1, there is the 1 value in the decimal portion. Then how is f come? Let's say 4 times 1. 4 times 1, go to the table, 4 times 1. So here 4 times 1, which is hexadecimal value is what f. So we have put it over here f. Then 0, 1, 1, 1. So it is going to be likely to be this one 7. So we have put it 7. Second will also 7, and the last is what? Let's say 2. So we have put it, and here we got an answer that is 1F772. So as a hexadecimal value. So this is what the calculation part of the hexadecimal numbers, IP numbers. And let's take the one example. And here there is example, guys. Change this IP addresses into the hexadecimal values. So in order to have this values, that binary values, we need to take these binary values. We need to separate into 4 groups. So we have separated 4 group early in examples. So let's take this only this one so that you can get the idea. So here this will be F, this will be F. But here after that, then second will be E, then B, then 0, then B, 0, 1, 8. But here there is a prefix, suffix is going to be added. We need to replace each group with the 4 bit as we process. And this note that hexadecimal notation normally has no address space or dots, no added space or dots. However, this is 0x capital or 0x small is going to be added to the beginning, or subscript to the 16 at the end, to show that the number is hexadecimal. So here subscript has added as a 16, and at the beginning 0x is going to be added to only identify this hexadecimal. This is what the hexadecimal number, because if we calculate any value, let's say 0, and something decimal value is something 0, so we cannot generally differentiate these numbers. So for that purpose, it's going to be separated via 0x, and it is going to be end via 16. So this is all about the IP address notation, guys. I hope this video has liked by you. If you have any doubt, you can put it over here and ask any question in the comment box. Thank you so much.